Very good morning, children. As we are done with our part on the topic rotational symmetry and the order of rotational symmetry, so I want to explain this exercise 18.2 of page number 160. As most of these were already discussed in our explanation, I am going to show how the answers are going to be. So just like me, you just write the answers with pencil. Find the order of rotational symmetry of the following pictures. So down to that they gave some pictures and they are asking us to write what is the order of rotational symmetry. That means when we rotate a particular figure in clockwise or anti-clockwise direction, how many times the figure is going to match with itself should be taken as the order. So as we have already discussed this, see, in each figure they gave one line, isn't it? That we call axis of symmetry. And the center point we point, see here, point is there in between the two parts. Such we call center of rotation. Look, so the first one, if you observe, it is carrying circular shape. That means forms a circle. So when we continue to do this rotation in this direction like this, so you will get infinite number of matches. I already showed this to you while I am explaining the properties of a circle for order of rotational symmetry. So infinite times it is going to match, hence write the answer as infinite. Okay, that means unlimited. Okay, so that's the first one. And the second one, I just explained this yesterday. So the letter Z is going to get the order of rotational symmetry as 2. So mark the answer 2. Okay. The day before I explained this one. So look at the figure once. 1, 2, 3, 4, 5, 6. Okay. So it is a hexagon. Okay. Regular hexagon. The figure indicates hexagon. And we start rotating this over this axis in this direction or in this direction. It will match up to 6 times. Hence, the order of rotation for this hexagon is going to be 6. And this one, you all know this, it is an octagon because look 1, 2, 3, 4, 5, 6, 7, 8. So, when we start rotating this figure or the picture over this direction, we will get 8 matches, 8 perfect matches, and hence the order of rotation is going to be 8. Okay, as most of the objects were already explained during our explanation for this topic, I am just going ahead. And this one you already know, 1, 2, 3, 4. 4 a square. So as we have already seen this, it is going to match for the 4 times. Hence the order of rotational symmetry for square is going to be 4. Okay. So next one, please be careful. Here the figure given is an equilateral triangle. That means this side and this side and this side all are of equal lengths. So for such triangles, as I have discussed, the order of rotation is going to be 3. Okay, the order of rotation is going to be 3. And this one, you please look. I will show you with a scale. 1 minute. So if you look, no need to draw this line actually, but I want to show you how the order of rotational symmetry is going to appear for this. So if you observe carefully, these two lines actually divided the given picture into 4 equal parts. That means when we start rotating this figure along this axis, this, okay, one will coincide when we come to here, and again it will coincide here, and again it will coincide here and to the original position. Hence for this figure we can say that the order of rotational symmetry is going to be 4. Okay. Now the last one, 8th one, for this also look. if we start rotating this figure along this axis, okay, if you check this petal, or if you take a point here and you rotate it, even then also you will get 3 as the order of rotational symmetry. Okay, because this one will coincide this side one time and here again, and when we go back to the original point, again it will coincide here. So the order of rotational symmetry for this picture is going to be 3. Hope you are clear. Mark the answers in the textbook itself and using pencil. No need to write in the CW or HW. Now I want to move to the next topic which we have already discussed. So that is down to that assignment 18.2. Okay, and that is 2D shapes and symmetry. So if you observe in our starting class itself, we discussed these figures, that is square, here it is equilateral triangle, next is pentagon. Pentagon means, okay, closed figure with 5 sides we call pentagon, and this one is hexagon which we have already discussed, and octagon. Again these things as we have already discussed, and some of these were already written in the CW, no need to copy again. So as we have already discussed this one, I want to move to exercise 18.3 which is in page number 161. I will show you how to write the answers. Please follow the instructions carefully. Okay, look. So first one, tick the correct one. A rectangle is cut into 2 parts as shown. Are the 2 parts symmetrical? That means, see here, they drew a line here and they are asking if this part, okay, just for your understanding I want to shade this one. They are asking whether this one is going to coincide with this one. Okay, certainly not, because until and unless there is a line of symmetry at the center, then only we will say both parts are equally divided. Hence, for the first one, you mark the answer as no. And then look at the next one. A circle is cut into 2 halves as shown. Are the 2 halves symmetrical? Observe carefully. So this line is exactly passing through the center of the circle. So hence we can definitely say that when we fold this side to this or this side to the other, both are going to be equal halves. Hence for this one, mark the answer as yes. Now fill in the blanks. The second Roman. A regular octagon has dashed lines of symmetry. Okay, for this one the hints are going to be in the page before. I will show you, look. So they are asking for a regular octagon has dashed lines of symmetry. Here the word regular is important because regular says that in that octagon all the sides are of equal length. Now let us see. So see. This one is octagon. Okay, this shape is octagonal shape. Check the note here. We can see that a regular octagon has 8 internal angles and 8 lines of symmetry. So for the regular octagon, the answer is going to be 8. Okay, this one I already showed to you when I am discussing this concept of symmetry. Now an equilateral triangle has how many lines of symmetry? So look at this figure. This one is the equilateral triangle. So equilateral triangle will have 3 lines of symmetry. Okay, equilateral triangle. Next one. A regular hexagon has dash lines of symmetry. I will show you the figure hexagon. So this is hexagon. We can see that a regular hexagon has 6 internal angles and 6 lines of symmetry. Hence our answer is going to be 6. Okay. Hope you are quite clear with this concept. Just for today, only fill up this exercise 18.2 and 18.3 in the textbook. Okay. Hope you are clear. We'll meet you in the next class with a new concept, that is symmetry in 3D shapes. That's all for today. Have a great day.